Hey guys, welcome back to another video. In today's video, I'm showing off this OpenGL C++ demo I made, and if you can see, it's like a 3D world that we can move around in. And we can see that about 4 of the cubes are spinning every third one, and I can use WASD to move around, and then Q to move up and E to move down. And if we go into the source code, so we can see we have the same OpenGL include, lat include, but we also have this one, which is OpenGL Mathematics, and that lets us do matrix transforming, and that's how we get like the 3D rendering. So the first thing we do, well, this is the new vertexes for a cube. We only have to declare it once, and then we can just repeat it 10 times, like this. But the main thing we're doing is if we go down here, we create a player position as a vector 3, and we set it just 3z back from the world origin. And then what we do is in here we create 3 4-dimensional matrices. We create a model, a view, and a projection. And what the model does is it just rotates the camera a little bit and sets it back. And then the view, we move the view by the player position, like we offset where it is, and then the projection gives us like a 45-degree FOV, and then it gives us an aspect ratio, which is 800 by 600, and it's like how it makes it so that if we load it, stuff in the back is smaller than stuff in the front. That's what it does. And then we basically just store all these values and then send them to our vertex matrix. And then for our rendering thing, we just render it 10 times. We just make sure to translate it again by the cube position. So each time we run it, each cube will have its own position, and then the camera modifies its position too. So that's why we can get up close to this one and we'll only be able to see this one. Or if we go back to the start position, we can see all 10. And then in the vertex shader, what we do is we take a uniform, so that's like an input from the main file. We take model, view, and projection, and we basically just times them all together by the position. And then we don't do anything different with the fragment shader. But what this does is it basically, instead of just saying that this, like the rectangle appears from 0.5 to negative 0.5 on the screen, we basically determine what part of the screen the cube will take a part of by multiplying the rotation, the camera view, and then the camera's perspective. And that gives us this like 3D world that we can move around in. Alright, that's all I wanted to show you in this video. Click here if you wanted to see the previous OpenGL C++ demo, and until next time, see you.